I'm Liz Sommerville, lead forecaster up at the National Weather Service in Corpus. I was not on the ships with that. I'm not doing that. That's not me. So today I'm just going to talk a little bit about sea fog. It's a little bit different. Let's see if this is going to work.
Try pointing it towards the projector.
I broke it. Sorry. They turn it on.
Do it with
I can just do it from the keyboard. So
It's registered at something. Yeah.
I'll start with the keyboard. It's no big deal.
I know what the problem is. Okay. Now it should.
So we talked about how there were no technical difficulties, so we jinxed it. Just a little bit about the Weather Service. We have actually 123 stations all over the country, and that includes Samoa and Guam. We have along the coast, the Gulf Coast, we have all of these offices here. Obviously, I'm at the one here in Corpus Christi, but we all work pretty closely together. Even down in Melbourne, Florida, we're actually one of their backup offices. So they go down, we take control for them. We go down, they take control for us. So we work very closely together, and our job is to protect life and property. Yes, we're in the Department of Commerce, so of course we're looking at the commerce and trade and economics, but really our primary mission is life and property. So today I'm just going to talk a little bit about fog basics. There's different kinds of fog. Not a lot of people know that. It's kind of weird. It all looks the same to everyone, but there are different kinds of fog. We'll talk about rain dense fog advisories. We'll talk about a site you guys can look at called the Port site. It's pretty neat. I kind of like it. Then we'll talk a little bit about fog prediction, some of the advances, some of the limitations that we have. And then I'll give you guys a seasonal outlook. And then if there's any questions, you can shout them during the presentation or you can shout them after, whichever is more comfortable for you. So there are two types of fog in South Texas, southern Wisconsin. Radiation fog, which is basically on land. So, you know, we get those cold, clear nights and the land was warm at night or during the day, and we'll get some fog in the morning usually. I like to call it the sunrise surprise. Right. So that's when we generally see radiation fog. It's dry a lot. You have warm or more moist air at the surface, and we'll see fog. Marine fog is different because it actually forms over cold waters. So it's a different process. It's not really the same as what we see over land, which sounds weird because you're just sort of like, well, does that matter? But it makes forecasting it extremely difficult. With marine fog, we want a little bit more wind, actually. We don't want it to be still. For land fog, you want it to be still. You want it to be warm on the ground, warm, moist air. For marine fog, we actually need a little bit of wind. We need more moderate wind. And then I need cool water. And I need warmer, moister air moving over the top of the water. And that's how we're going to get our fog to develop. Generally, what we see is fog in November to March. We're kind of in the middle of fog season. So I'm sure you've all woken up to see just nothing out there. So we get generally some surface boundary will come up. We'll get dew points that are a lot warmer than the water temperatures. And we get these cool shelf waters. It's kind of unique to the area because we do have those shallow waters just right off the shore. So those waters cool a lot faster than some of the deep water. And that's how we can get these moisture coming across and we get the ingredients building together to build sea fog. So one of the things we do talk about is that it is favorable fog here in the Gulf Coast. It's a weird geographic area because we do have, as you can see, got a little pointer. We got the continental shelf here. So it's really not very deep. And what we see is that this water's cool a lot faster than say these waters out here, which is actually good for us. Well, it's good for sea fog because you're going to get warmer air that kind of comes up through here and goes over these cooler waters. You're going to see that we have most of our forecast area is going to be over this the continental shelf. So you're gonna see more fog in our area than you will, say, if you go farther out. We also have a lot of waters that are draining into the Gulf, right? So we have the rivers that kind of move through, and when they all empty into the Gulf, and those waters are usually much cooler. So it's also helping to cool the water, cool the waters right there. So it makes it even more difficult for us to keep those waters warm so they don't get hot. So you can kind of see here, water temperature. So as you can tell, water temperature is pretty much one of our main focuses for sea fog. It's not the same everywhere. So it's kind of frustrating for us because if you look at the bays, like even in here, you can see it's all different. So different parts of the bays will have different temperatures. So you'll even see that in the Nueces Bay. If we get a particularly, like a north wind coming in, we might get fog in the southern part of the bay where it's cooler waters. The northern part of the bay is actually warmer right now, and so we don't get fog. So that's one of the tricky parts about forecasting fog is where are the water temperatures different? So we have to monitor that pretty much every day, all day. One of the big things that we see is that with cooler winters, obviously we're going to get more fog. Water temperatures drop a little bit more, and it's just easier for us to get the warmer dew points coming in and the colder water temperatures, and so we're more likely to see fog. One of the big things that we noticed is that the window for marine fog is really January, February, March, November, and December. So once we get into the summer months, water's warming up, we really don't see a whole lot of sea fog. The wind direction actually matters as well. Southeast winds. So the water coming up, again, radiation fog, we want it to be still. Over the land, we don't want any wind. But over the waters, we really need that warm, moist air to move across. If it's still, that air has a chance to mix out, and we don't see the processes that build any fog. You don't get the condensation, you don't see that. So you actually need a bit of a puff of wind there from the southeast, bringing it up over those Gulf waters, the warmer waters, into the cooler waters. So that is the predominant wind we're going to see in Port-Aransas for March, for November to March. We generally have a southeast wind. So all we need to see is dew points and the water temperatures really close together. Closer together, the better it is for fog. So we issue marine dense fog advisories. You'll see these graphics like this on our webpage. So what we do is when we issue a marine dense fog advisory, it's for 1 nautical mile or less. Over land, when we issue a dense fog advisory, it's 1/4 mile or less. So it is quite a bit different, but obviously that's for the hazards makers. So see, some of y'all were Navy, so we kind of know what I'm talking about. It's you don't want to be stuck out there when you can't see anything. And our most common advisories are in the cooler months, February and March. They're our busiest months for it. So we're going into our heavier months for fog. Although this last November, we did have quite a few dense fog advisories because we had that cold blast, and then in December as well, we had that cold blast. And then time of day. So this is a little bit tricky because yes, we talk about how we do the most likely time of day for dense fog advisories are between 3 a.m. and 10 a.m. And then we're least likely to issue them between 12 and 7. That does not mean that the fog is not there at that time. What that means is that's what time we start to see it develop. And we're going to look at it and go, okay, that's when I'm issuing it. It doesn't necessarily mean that there's not fog at noon or at 7 p.m. It just means that's when we're issuing that advisory. So I don't always love this graphic, but some people are very interested about when we issue them and what time they should be expecting it. So I included it. One of the big things about sea fog is that it really messes up our commercial traffic. The port shuts down. It has to, it's not safe. The pilots can't go out and they can't do what they need to be doing. It's just too dangerous. So one of the things we've noticed is that This is from November to April of last year. So this is our sea fog season last year. About 400 hours closed. Time. When they close, it takes them time to ramp up. It takes them time to ramp down, and it costs money. So one of the things we try to make sure we're doing is getting our sea fog advisories out on time, because that is tricky for them. As you can see, for instance, this one here, we had a very strong cold snap. Highs dropped from the 80s into the 50s. So it lowered our water temperatures really rapidly. And when the wind shifted back, we had some pretty good sea fog develop. This is just a graphic of the water temperatures from October to April. And you can see again, kind of where it was dropping down. And you can see here where in February, March, got a lot colder temperatures. Even though warmer temperatures might be moving in for March, the water temperatures take a lot longer to rebound. So we can see the cold fronts, they can cause significant drops in water temperatures. It can take weeks. When we had the one in February of 2021, it took 2 or 3 weeks for the water temperatures to run down. We had sea fog every day for that. And it didn't clear out in the afternoons. It didn't clear out when the sun came up like normal land fog does. It just stayed because those waters are just too cold. For our fog frequency by month, climatology of it is generally that it's, again, November through April. December, January, February, March. That's when we're going to see it. February, March are the biggest 2 months. And we notice that it's we have the closure start times just kind of for this long period, just sort of as a, what does it look like for us? We notice that the fog generally starts to develop a little before dawn, and then it keeps going, and it can go all the way through the day. And then if it doesn't clear through the day, it's not clearing overnight. It's just going to keep going. So we're going to keep having fog. So we really, if we're lucky, it clears out about noon. But when the Matagorda pilots and Port-Aransas pilots call us and say, is it going to clear out? And we're like, yeah. It's very frustrating because we're really hoping that it does. It doesn't always. And that can be really tricky for us all. So I don't know how many of you guys are out going out and sailing or doing whatever it is that you want to do on the water. But we do have the availability to get these marine dense fog advisories and other advisories, rain forecasts as well. You can get them through the FTP mail. You can get them through weather radio. One of the things that I really like before you go out is the port site. I don't know if any of you have seen this. So we have a bunch of really good sensors. We have them, like this one shows the wind observations near Port-Aransas. It's just a really cool kind of website that shows us the real-time environmental observations. And you're able to kind of get some of the forecasts on it, but you can really see it real-time in the location that you're looking for. You can get water levels, salinity currents, visibility, and other temperatures, water temperatures. So it's a pretty cool site, actually. Basically, what we're looking for with it is it's a sort of a group effort where we've gotten together and tried to get the navigational safety in there. We want efficiency for ports and harbors. We want to make sure that everybody is safe out there. That's what our primary worry is that we want you guys to be safe out there. We want to make sure that people who are out there researching, people who are out there doing the turtle rescues, they're safe as well. So this is actually a really good site for us that we can use to kind of just a one-stop shop for us. One of the things you can see is that we have drop down. There's other places that have a ports menu, so it's not just Corpus. It's actually kind of a pilot project. So we have it in some different places, but Corpus is one of the places that we were actually fortunate enough to get this. You can kind of go through and you can actually customize this menu so that you can see what you want to see. We use it to drop down the filters, the sensors and water data and everything. You can click the map and you can kind of see, got one here for you TMSI, which we really appreciate a lot. We use it quite a bit. So we have these, all of these are just visibility sensors. All we're doing with these is looking at visibility on this particular one. Now, they have other sensors as well on these sensors. We're just using the visibility for this demonstration here. One of the things that we notice is that we have all these sensors, but you can see there's huge holes. So we can't really see where there's fog everywhere. And as I said earlier, you saw how the bay temperatures can all change. We can get fog in places we can't see. So it can be kind of frustrating. One of the things I just set up here real quick was when you customize it, I was able to put all of the visibility sensors here. Obviously today, there's not a whole lot of visibility issues, so it's pretty boring. But generally, it's pretty good. You can kind of see how these will drop and you'll see where the visibility is down and it's up. It's a really neat web page. And it's all just on the tides and currents page that NOAA has. So we'll kind of talk a bit more about some events. The January 2021 fog event. We did see that there was some fog that was indicated on the visibility sensors. And we use those to see where there is. We also use satellite to try to see where the fog is developing. We use webcams. We use every tool we can find to try to see what's happening. Basically, the way before these visibility sensors, all we had was mariner reports, which we don't always get. We had satellite data and we had inland stations. We had to hope that the fog was advecting on shore so that you could tell that there was some fog out there. It didn't work very well. So with these visibility sensors, just help us a lot. And we also got Port of Corpus Christi has now let us have access to their webcams. So that helps us a ton. Now we're able to see the ship channels as well. One of the things that we saw is, if you look here, the first hit of fog we had, it dropped down to almost zero visibility. We don't get a lot of warning for this because when the fog develops, it develops. It just goes. It's real fun. So it'll kind of go through, and then you can see it even raises up a little bit and then goes back down. So fog will kind of continue and it can lift, because as you know, fog isn't still, it moves around. So it can kind of blow out for a while, come back in, blow out, come back in. So we generally leave our advisories running for a pretty long time. So you might go out there and say, hey, there hasn't been fog out here for an hour. We have the advisory going because there's still fog somewhere else, or that's pretty close by. So that's one of the things that you'll kind of see out there with us. You can always relay reports to us through these fog numbers. These numbers, fog reports, like I said, help with new forecasting. So the meat and potatoes of it, fog forecast. If you watch the stoplight, you can kind of see there's a pattern to it. And that is one of the things that we're going to use for forecasting. Persistence. We want to know, what is the pattern we've seen? A lot of meteorology is based on persistence. What do we see? It's pattern information. That's why when you have a meteorologist who's been doing it for 40 years, you don't discount what they're saying, regardless of what the models, because they've seen it and they know the pattern. So in this case, we see the sea surface temperatures. We have visible satellite, and you really don't see a whole lot on the visible satellite. It's pretty quick. And we have our dew point temperatures. That's what these lines are. So we can see that our sea surface temperatures are fairly warm here, but when you get close to the shore, they're a lot cooler. And you have these warmer dew points kind of moving in from the Gulf. Again, not a whole lot on the visible. You can kind of see a little bit of gray coming in through here, but not a whole lot. And you see the surface winds are kind of moving in, coming up more toward the shore from the Gulf. So we're getting that moisture moving in. So we're looking at this saying, well, what can happen? We're looking at model data here that says, well, the dew point temperatures are going to be increasing. We see that the surface winds are still going to kind of be going the same, coming from the water into land. So we're looking at that thinking, well, what can happen? Any guesses? Looks foggy, right? So we're looking at model data again, and this is actually an interesting one. It's probability. So when we forecast fog, we don't look at it, here's where fog's gonna form. We have to do it by probabilities. How is fog gonna form? When is it gonna form? So we're looking at it saying, okay, well, here we see fog. And here, there's a slight chance of some fog. But we're not sure. So we have to kind of know, based on what we're seeing with the patterns, with the winds, the sea surface temperatures, the dew points, what's going to happen, because sometimes the models cannot pick it up. So one of the big things that we have a problem with, again, back with the models not picking it all up, we can get clouds that block our view. Is there sea fog? I don't know. Because there's stratus in the way, you can't see it. We have limited observations, water temperatures. Timing can be off, especially if it's slow moving. So that's one of our big forecast challenges. And sometimes it just doesn't form. Sometimes it does. And also, why? So we think we know, and we try to do our best guess, and we try to do our best science on this, and try to make sure that we're keeping things, you know, scientific and following the rules and following how this goes. But sometimes the atmosphere does not agree with us. Steep, so it's tall, and different things can happen. It can be one little hiccup over here that causes something. We all know about chaos theory, where the butterfly wings, right? Flaps and rings the next Ecuador and causes rain or whatever. I mean, it's like that. It is very much one little thing can set it all off. And since we don't have the observations that we need, really, sometimes we just don't know why it's not going to form, which makes it frustrating. So another time we had this, we had the onshore flow. We had light winds, moderate over the water, you know, 10 to 12. But light winds over land, mostly clear skies. So the land cooled. We had light winds over land. And as we said before, that's fog over land. What is that over the water? Who knows? So we looked and see the winds are here. We have these dew points that are in the 50s. And we saw that we had onshore flow and the water temperatures weren't very cool. So we decided that marine fog was actually not expected because water temperatures, time of year is really, that's what we're looking for, is the water temperatures here. So we needed them to be a little bit warmer, but sometimes we do get fog that moves from land over the seas. What's the difference? So to mariners, it doesn't really matter, right? We still have sea fog versus radiation fog. They don't care. So sometimes we get this fog that actually just drains into the bays. So on this day, we didn't technically have any sea fog, but so all of our low visibilities, this is just a model data that shows whether or not we have low visibilities. This thinks it has low visibilities here with the pink. And as you get into the greens and everything, it's higher visibility. But nothing is shown over the waters. Same thing with the, this is called, we call it the HER. Even though it's HRR. It's the HER, it's just too hard to say those R's. So we see again, lower visibilities over land, not over the waters. Same thing with all of these models, basically. So one thing we did was we didn't issue the dense fog advisory, and we see that it did not come into the waters. Fog lasted quickly, or lifted quickly in the mornings. Didn't have to worry about it in the Gulf, in the bays or the Gulf or anything. However, we did notice this little dip here at Tule Lake because fog moved in. So it just likes to give us, I think, this what it is. So one of the things that you can do is you can look up to see if you're getting ready to go out or you're just interested in it and you want to see, you can go look. There's model data there that's available. You can find the visibilities to see what you're looking for. See if there is any chance for sea fog or regular fog. It's all available to you. There's no indication that's there's no reason why you couldn't also go look at it. But again, like I said, it's pattern recognition. You'll kind of have to learn some of that, but it's not. You can always call us and ask us if you want to. So kind of just finishing up here, we've got the seasonal outlook for this season. So 6 to 10 day temperatures, we're seeing that we're looking at below normal temperatures. And same thing for 8 to 14 days. That means our water temperatures are likely to cool. So in the next few weeks, there is more chance for us to see some sea fog, especially since the prevailing winds this time of year do tend to come from the southeast. So we're looking at more chances for sea fog. However, seasonal outlook says mostly it's above temperature. So the Climate Prediction Center is they get some interesting ones. So, but since we're looking at that, that means that we're expecting the rest of this season to not be as foggy as it could be. However, in a cold front, and like I said, with these upcoming cold temperatures, we absolutely could see some sea fog. So if there's any questions, I know it's hard to get excited about fog. You know, sort of like the unsung hero here. You have one?
You said the dew point is close to something else. Water temperature?
Sea temperatures, yeah, sea surface temperatures.
Could you explain dew point?
The dew point, okay. So the dew point is the temperature where, when the temperature and the dew point meet, that's where water will condense. So when you have the dew point reaching a certain point, that's where our water's, that's basically the condensation temperature. It's similar to it.
Yeah.
So that's where you're gonna see that happen. So you're looking for where is the moisture at versus the sea surface temperatures.
When they get close, you can fall.
Yes.
Sea fog.
Correct. Did you have a question?
Well, I was just thinking about the radar on the ships. Don't they have good radar? They just have to go a little slower in the fog or something, but they could still travel, right?
Yes and no. Because they can't see everything, you know, radar is not, it's not perfect. It's not safe necessarily, especially in the narrow channels. You know, a lot of times we have the pilots that come out and they go and they help guide the ships, and if they can't see where they are, it's hard to determine, say there's something under the water or something that they know there's a threat nearby that they know that they need to kind of move around. They're not able to see that, and it's just not safe. Plus, it's not just them, it's, you know, you can't move a big ship fast.
Right.
So the big ships have radar, those little ones don't. So they're gonna go out there and not be able to see. And if the visibility is less than a quarter mile or there's a mile of a ship's coming across and they don't see it in time, it can cause a pretty bad accident. So that's why it can be so hazardous. And the port shuts down for that purpose too, because sometimes you just can't see. It's just not safe to operate. Yeah.
What type of structures here in Port-Aransas do you have sensors or webcams? Where would they be?
Well, we have one here. There is a webcam.
Here at UTMS.
Mhm.
Okay.
We do have a sensor here. We have a few around. Let me see where they were. Let me go to the map here and find it real quick. We have a few. There used to be one on Bob Hall here, but of course that doesn't help us now.
Yeah.
So but we do have, let's see, here we go. Show you that. You can see we have them, yes, we're keeping some on the jetties, some of them are at the aquarium, and there's just a few places where they're placed. There's generally just a small station where they're kept. The webcam, same thing, it's kind of, honestly, for the webcams, the Department of Transportation has great webcams. We just steal those. And we also use the ones, the condos. Have webcams, so anything that has a public webcam, we're pulling it up.
On that chart, what do the red and yellow colors represent?
Those are what kind of stations they have, so this is like visibility. This one would have, I believe it has fewer sensors than some of the other ones. So that it just has to do with what types of sensors they have.
Other than visibility?
Correct.
What is there other sensors?
Salinity of the water, currents, temperatures, winds.
Yeah, you mentioned the, excuse me, The visibility sensors, how does that work?
Well, they have,
Obviously, if they stick something out that reflects back, you can't see that way, but,
a lot of times, it depends on the sensor that it is, but a lot of times we have them where they have like a mirror. And if the if the temperatures come within a certain distance, the mirror will fall. And you can see it like that. There's other ways too as well, but I mean, that's the long and short of a visibility sensor. There's kind of a lot to them. It depends on the sensor, of course, but
so you're not actually measuring visibility, you're measuring a surrogate for it.
could be. It depends on the sensor. Like I said, some of them do have a sensor where they kind of measure the visibility itself. They try to measure how far out they can, the light will reflect or whatever, but the majority of the time it's most of the mirror.
I worked in the aviation field there on weather station. And the visibility sensor has two angular things, and they're pointing into air. One's a transmitter,
Mhm.
and then the other's a receiver. So depending on how many particles are reflected by the amount of moisture, things in the air, reflected in the receiver, it can tell the mileage, even though it's only 3 feet apart, it can tell the mileage 0 to 10.
Different, there's
Bouncing off the part.
tons of sensors. It's a really interesting how they can,
Yeah.
different sensors can do different things, but like, I think some of these are like that, some are
Yeah.
the older types. It just sort of depends on which visibility sensors they're using. I'm not sure with all of these. Thank you.
How do the commercial ships that stay in contact with these folks, how do they navigate through all this stuff?
They don't actually, it's not us. So all we're doing is providing the forecast for them. They have the harbor masters, they have the pilots, the ports, they have tugs, they have all of those people who do that. Plus they talk to each other and they're through their parent companies. They don't usually talk to us. Basically, all we get is a report from them from the weather if we go click for it. So we have to go out and actively seek their reports. We don't actually hear from them. Even when I was at the Ocean Prediction Center, we did not hear from the ships. We had to go actively find their reports every day. So they don't, the Weather Service is not allowed technically to go out and provide a routing forecast for them. We can just provide the weather information for them.
Relative humidity, did that play in here at all on sea fog?
It does. So relative humidity is basically a measurement that kind of describes where the dew point is and the percentage of moisture in the air. So you kind of take the dew point and the temperature and average them out kind of and make a percentage, and that's how you get it. There's also some other things that can go into relative humidity, but those are the two main things that we're going to see for relative humidity. It's just a percentage.
So that would be more on land fog than sea fog.
Do what?
Would that come and play on land fog versus sea fog?
It does for both.
For both.
It does for both. The interesting part about sea fog is that relative humidity plays a lower percentage in it. Relative humidity, if I can see 100% relative humidity on land fog and radiation fog, I'm gonna go with fog. It's not that difficult. That's pretty, as long as there's no winds, that's pretty easy. Over the waters, it can be 100% humidity, but I may not get it because the water temperature is enough to keep that lower air mixed. So, we get warmer air, it's gonna rise. So if the water temperatures are warm, we get the warmer air that rises and it kind of mixes out that moisture. And we don't see the fog. When you have the cooler water temperatures, that air is not rising. And that's why it doesn't mix out and we tend to get fog. That makes sense. Any other questions?